In an era where data is king, RDBMS stands as a beacon of efficiency and consistency, cutting through the chaos of redundancy. Join Vishwa on a thrilling journey into the heart of database normalization, from the uniqueness of the first normal form to the seamless integrity of the third. Discover how RDBMS crafts data not just for storage, but for perfection, ensuring each piece is as reliable and interconnected as the pieces of a puzzle. Dive into the world of flawless data structuring, where every transaction is a success story. Get ready to unlock the full potential of your data in this segment. Let's transform information into a fortress of reliability together.
So we have been talking about the features of the RDBMS, and we have already covered the tabular structure, and we also talk about the primary and the foreign keys. The next feature that we are going to talk about is normalization. Remember, we have been talking about file-based storage system, in which one of the biggest disadvantages was data redundancy. Now this is something which has to be addressed by the RDBMS system, and we try to do it with the normalization. But normalization doesn't happen on its own, it has to be done. Like even if you're using a relational database management system, if we don't bring normalization into the picture, you still have the data redundancy. Let's try to take that with the help of an example. So for example, we have a table right now which is giving the information about the employee. So this table right now has 4 columns. One is employee ID, the another is name, then we have something called city, and we have something called project ID. So this is right now a tabular representation of our data, a tabular representation of an employee, which is depicting what is the address of the employee, what is the name of the employee, what is the employee ID, and also to which project it belongs to. But if we try to look deeper into this table, you will figure it out that there are so many records which is repeated. So for example, you can see the name Rohan has been repeated multiple times. The city you can see is repeating multiple times, and so is the case of the project ID. So then what is the advantage of using RDBMS? Like in the file-based management system also we have the duplicacy of the data, and still also since we have not done it right way, this is a denormalized form of data in which the data is repeating one after the another. There are multiple disadvantages if we still use the table in the same format. The different kind of anomalies that can happen, and we'll try to take it one after another in the same example. The first and the most biggest problem that one can face if they keep the data in the denormalized form is the insertion anomaly. Now as you see in this table, you have the employee ID, you have the name, you have the city, and you also have the project ID. Suppose a new employee joins the organization. As soon as the employee joins the organization, he may or may not be assigning a project to it. So unless until an employee has been assigned a project, there is no way that you can go and add that data into this table. So for example, if the project ID is a not null field, unless until you have assigned a project to an employee, till that time you have to wait to add this data into this particular table. Another way is that you assign the value as null, which actually doesn't make any sense. So this is one of the problems in which if you have not properly organized your data in the table, you will also have problems in inserting the data into the table itself. So this is what we call as the insertion anomaly. Let's take another example of the updation anomaly, right? So suppose now we have stored the data, but my use case is to update few of the fields. So for example, say city. So as we are seeing right now in India, there is a trend of changing the city names, right? So suppose fortunately or unfortunately somebody changed the name of Delhi to something else. Now since Delhi is present in the multiple rows, right? One will have to go to the multiple rows and change the name of the Delhi, which again is a cumbersome task. Now we are actually moving back to the old days of file-based storage system itself, right? Where if we have to change something or update something, we have to go and do at the multiple places. So similarly is the case here. So in the city table, the name of the cities is is duplicated, is replicated at the multiple rows. If tomorrow the name of the Delhi changes to some other place, we have to go and update at the multiple rows. So this is what we call it as the updation anomaly. So the next kind of anomaly that can happen in the case of denormalized scenario is deletion anomaly. So it is basically a kind of complicated situation in which you want to delete something and which results in an unwanted state. Take the example of this. In this table, we are not only storing the employee information, but we are also storing the project ID information. Take example of say Mayank. Now Mayank is an employee whose employee ID is 123, and in this table it is a part of project ID D89. Now we see in this table only Mayank is a part of the project D89. Now suppose because of some reason the Mayank left the organization and he decides to move on. So as soon as the Mayank will leave the organization, the entry for the Mayank will be deleted from this table. Now if we remove the entry of the Mayank, with the same the project ID entry D89 will also get removed from the table. Now the problem is, since project as well as the user is so tightly coupled in this table, if I am removing any person's record from it, we are also removing the record of the project, which is actually not the case. Even now the Mayank has left the organization, that project ID 89 will still cease to exist. So this is the problem that happens if you store the data in the denormalized form. So we need to take some steps to split this table into a more better way so that the data is normalized. So in the coming videos we'll be talking more about how to come out of this problem, convert a denormalized table into the different normalization form and avoid the data redundancy. So we have talked about previous session that how if a table is in a denormalized format, the different kind of anomalies can happen, like insertion anomaly, updation anomaly, and the deletion anomaly. To fix it up, there's something called normalization. But again, there are different stages of normalization that we have already discussed about. So the first stage of that is the first normal form 1NF, and then the second, and then the third. So right now we are going to discuss about the first normal form.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by Upgrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now back to the video.
So the first normal form says that there are few conditions that it should satisfy if a table has to stay in a first normal form. The first and the most important condition is that there should be no one cell couldn't have more than one values. So for example, in this table players, the sport column right now has a multiple values, which is indicating that this particular table is not in the first normal form. So the very first requirement of a table being in the first normal form is that any cell cannot contain more than one values. In other ways, there could not be two columns in a table which means the same thing. So for example, we cannot keep one more column in this table for say sports 1 and the sports 2, because both of the columns means the same thing. So again, if we do that, it will not be in a first normal form. So the first thing that we have to look out for is that any cell, if there is any which have any multiple values in it, then it is not in a first normal form. Multi-value not allowed. The second thing is that every row in a table should be uniquely identified. Either you do it with the help of a single column, or if you can combine the multiple column and still figure it out if a row is unique, you are good. So we'll try to see, this is our given table which is players, which has like 4 columns: player ID, name, age, and the sport. And in the sport column for a player ID P01, I have multiple sports multi-values there, right? So this is obviously not in the first normal form. So what we can do is that we can split this single record, this simple single record, into the 2 records. So what we have done is that we have split that into the 2 records. So now the number of records in my new table has increased, but now we have satisfied the first condition, that is there is no particular cell in this table which has the multi values in it. Now let's try to talk about the second thing, which says that each row should be uniquely identified. What it means is that you should know few columns or a combination of columns which can uniquely identify any particular row in this. So in this table, if I take a player ID column and I take a sport column, and if I concatenate both of these, I can always figure out every row as a unique entity. So again, it is satisfying both of these conditions. So I can now say that this players table has now been converted into a first normal form. In the coming videos, we'll be talking more about the second normal form and the third normal form. So we have been talking about the normalization and the different normalization form. We discussed about what is a first normal form. So let's move to the next higher level of normalization, which is a second normal form. Before taking into the example, let's try to first understand what is a second normal form. So for a table to be in a second normal form, it has to satisfy two conditions. The first condition itself is that it should be first in the first normal form, and the second important criteria is that if it is in first normal form, none of the columns in that particular table should be partially dependent on the primary key. Let's try to understand what I said just now with the help of a proper example. So we have a table called subject marks related table, which has the information about the students, subject, marks and the teacher, right? So in this table, suppose my primary key is composed of student ID as well as the subject ID. So if we combine the student ID and the subject ID, I can uniquely identify each row of this table, and that is why I can say that this table right now is in the first normal form. Now let's try to figure out what was the second definition of the second normal form. So the second definition of the second normal form says that each of the column of this table should be fully dependent on the primary key. Now let's try to see if it is true for this or not. So let's say for example of a marks. So when I say a marks, the marks has a full meaning only if I mention both the student as well as the subject. Just saying what is the marks for a student doesn't make any sense, because you need to have the information about the subject also. And if you just say what is the marks in a particular subject, unless until you provide the student name also, it doesn't make sense. So I can say this, the marks column is totally dependent on both student ID as well as the subject ID. Now let's talk about this column teachers. Now this teachers column is only dependent on the subject. Now the teacher doesn't depend on who the student is. If a teacher is teaching chemistry, he will only teach chemistry. It doesn't depend if the student changes, he will start teaching maths. So this teacher column is only dependent on this particular column. So what I can say that since the primary key right now is a composite key which consists of two columns, student ID plus subject ID, but the teacher column is only dependent on the subject. It is not dependent on the student ID. So I can say that in this particular table, the teacher column is only partially dependent on the primary key. And that is why it is not right now in the second normal form. It is in the first normal form because each row can be uniquely identified by the help of the primary key. But it is not in the second normal form because there is a column in this table which is not fully dependent, which is only partially dependent on the primary key. So in order to convert this table into a second normal form, we'll have to make sure the columns which are partially dependent on the primary key should be moved into a different table itself. Let's try to see how we can do it. So what we have done is that we have broken this whole table into two parts, into two tables. So the one of the table is the subject table. Now the subject table has now two columns. One is the subject ID and another is teacher ID. Now we can see the subject table has a unique subject ID which is its primary key. So it is in the first normal form, and also the another column which is there in this table, say teachers, is fully dependent on the primary key. So it is in the second normal form as well. So the subject table is in the second normal form right now. Let's try to see another table that we have created with the help of the first table, which is marks. Now this marks table now has four columns: marks ID, student ID, subject ID and the marks. Now this mark table still has composite primary key which consists of student ID plus subject ID. Now this marks totally depends on both the columns, both student ID and the subject ID. It's not partially dependent on either of these two columns. So now I can say that this marks table is also in the first normal form because there is a primary key which can uniquely identify each of the row, and is also in the second normal form because each of the column in this table is fully dependent. It's not partially, it's fully dependent on the composite primary key. So this is the key takeaway of the second normal form. Whenever you have to convert any table into the second normal form, we have to keep two things in the mind. First is it should be already in the first normal form, and second, there shouldn't be any column in that table which is only partially dependent to the primary key. If it is so, you have to remove that column and take it into the another table form so that all the tables that forms is in the second normal form. So this was about the second normal form. we'll continue our discussion on the normalization with the third normal form in the coming video. So we have been talking about the normalization and we have already covered the first normal form and the second normal form. Now let's move to the next higher level of the normalization, which is the third normal form.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by Upgrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
Before taking the example, let's talk about what a third normalization form would be. For a table to be in a third normal form, it has to satisfy following criteria. The first, it should be already in a second normal form. And third, there shouldn't be any transitive dependency in that particular table. Now, a new term, transitive dependency. So let's try to understand this term, what is the meaning of the transitive dependency based on the example that we have taken up. So let's talk about this marks table, right? So this marks table has a column named marks ID, it has something called student ID, subject ID, then it is a marks column, there is an exam column, and then there's a total marks column. First, figure out whether it's in a first normal form or not. For a table to be in the first normal form, it should have a primary key. So this is my primary key definition in this particular table. So in this marks table, I have a primary key which is a composite key consisting of the columns student ID plus subject ID. So these two marks as a composite primary key and uniquely identify each row in this table. So this table is right now in the first normal form. Now let's try to figure out whether this table is already in the second normal form or not. So I see there's a table called column called marks. Now this marks is fully dependent on both student ID as well as the subject ID. So there is no partial dependency here. Again we see a exam. So exam column also is fully dependent on the student ID and the subject ID, and there is no partial dependency on the primary composite key. And that is something called total marks, which does not depends at all on the primary key. So again it doesn't have any primary dependency on the primary key. So since none of the columns in this table is partially dependent on the composite primary key, so this table is already in the second normal form. Then I introduce a term called transitive dependency. Let's try to see what a transitive dependency is. A transitive dependency is a kind of dependency in which any column in a table is not at all any way dependent upon the primary key. So for example, in this table, if I take this column, example, total marks, this total marks is only dependent on the exam which it is there, right? This total marks does not depend at all on the student ID. It doesn't depend on what the subject ID is. Rather, the total marks is dependent totally upon another column which is not a primary key at all. So this kind of dependency in which one column depends on another column which is not at all a primary key, even not a part of a primary key, this kind of dependency is known as the transitive dependency. So in order to convert a two second normal form table into a third normal form table, the only thing that we need to do is that remove this transitive dependency. Now how can we do this? We can do this by removing the columns in the table which are actually transitively dependent. So what are the tables which are transitively dependent? These are the total marks and the exam. So these two tables are transitively dependent, and we'll try to remove that table into the another tables. So what we have done is that we have broken that marks table into the two tables. The first one is the mark table at is. So it has four columns, the mark ID, student ID, subject ID, and the marks itself. So now in this table, if you see, my composite primary key consists of student ID plus subject ID, and all the remaining columns, say for example marks, is fully dependent on the composite primary key. Like marks is totally dependent on this composite primary key, and there is no column in this table where there is a transitive dependency. So since it's in the first normal form, it is also in the second normal form, and there is no transitive dependency in this particular table. So now my marks table is become third normal state. Now let's take example of this exam table. So this exam table, again we have put the record of exam ID, we have put the record of the exam name, and we have put the record of the total marks, right? So again in this table, all the columns are totally dependent on the primary key. There is no partial dependency, so it is in the second normal form. and at the same time there is no transitive dependency right now in this table. So again this table is also in third normal form. So this is how I have broken a table which was already in the second normal form, but since it was having a transitive dependency, we removed the columns which are transitively dependent into the another tables, and we converted the second normal form into the third normal form. This is one of the highest level of the normalization which any company strives to achieve. Sometimes it is not practical to reach this, reach this state, but wherever possible we should always try to achieve as much higher level of normalization as possible. So this was all about the normalization. In the coming slides, in the coming video, we'll be talking more about the different advantages of the normalization and additional features of the relational database management system. So we have been discussing the different features of the relational database management system, and of late we studied about what does normalization, what are the different forms of the normalization. So the next feature that we are going to cover is about transaction and the ACID model. But before we move that, let's quickly try to revise what were the advantages of normalization.
If you've made it this far in the video, give us a like, a share, subscribe, hit the bell icon, tell us what you want to learn next in the comments, and then wait. Or skip the wait and become a data scientist in just 12 months with the Executive PG program in Data Science from IIIT Bangalore, powered by Upgrad in collaboration with experts from Meta, Myntra, and LinkedIn. Over 20,000 working professionals from over 65 batches have already done this course. Now, back to the video.
So there are multiple advantages if you go for normalization. First is that you avoid the redundancy. So as soon as you sort out the problem of redundancy, the different kind of anomalies that can arise, like the ablation anomaly, the insertion anomaly, and the deletion anomaly, it will automatically go away. So this is one of the advantages of using normalization. The another good point of normalization is that it helps you to better structure your tables. Your tables will be more meaningful and they will hold better relationship among each other. The third better use of normalization is that it helps you to write a very efficient query. Since you know where your data are and how they are rearranged to each other, it helps you in writing a better efficient queries. So that was all about the normalization. Let's move to the next feature of RDMS, which is transaction. So transaction is very important. Previously also when we are talking about file-based storage system, one of the biggest problem with the file-based storage system was it cannot store transaction. So let's first try to understand what a transaction is. Okay, so suppose for example, take example of bank, right? Now, when we take example of bank, one of the most common phenomena that happens in the bank is the transfer of money, right? The money is involved, and we transfer the money between the two bank accounts. So for example, say there's a person A and there's a person B, right? And the person A is trying to send say rupees 100 to the person B account, right? So unless until the time from when A initiated the process of taking out the money from his account and then pushing that amount into the B's account, and unless until the B account has been updated with that amount, the whole three-step process we call it as a complete transaction. So we can say like one is that A money deducted. The second step can be money transferred. And the third step can be B money added. So transferring of the money from this A account to the B account consists of three steps, in which the first step is that the money got deducted from the A account. The second step is that money got transferred from the A bank to the B bank, and the third step is finally the money got added to the C's bank account. Now all the three steps, when combined together, they form a transaction. And what it means is that if there is a failure happening at any of the steps, for example, if the failure happened at the first step itself, so automatically the A money which was getting deducted from the A account will be reverted back. If the failure even happens at the step 2, again, whether the first step was failure or a successful, since the second step failed, it will again go to the initial state. And even if the failure happens at the third stage itself, still the money will go back to the A's account itself. So the transaction means that if it will happen, all the three steps will be happening completely. But if it fails, it will go to the initial state. This is what the meaning of the transaction is. So in any kind of banking firm or any kind of organization where we want the confirmation of the event to happen, when it consists of multiple steps and we want that all the steps should happen, either all the steps should happen or none of them happen, this kind of scenario is known as the transaction. Okay, so any relational database management system which has to support this kind of support of transaction has to provide support of these features. So RDBMS, for example, MySQL or the Oracle, which supports transaction, they help in the transaction model with the help of these four features. These features is known as the ACID model. Okay, it is basically an acronym where A stands for the atomicity, C stands for the consistency, I stands for the isolation, and the D stands for the durability. Now we'll try to understand each of the term and understand how each of these individual features helps in the transaction to happen. It helps in helps MySQL or the Oracle or any RDBMS to support the transaction. So let's talk about the atomicity. So the atomicity means either all or nothing. So atom has been taken from the word called atom. So atom is the smallest particle, in any kind of element. So what it means is that if we are going to do a transaction, anything should be atomic. Either it should be fully done or it shouldn't be done. So this is what the atomicity guarantees. So since MySQL supports atomicity or any RDBMS support atomicity, it means that either it will happen or it will not happen. This is the meaning of atomicity. Now let's talk about the second part of this ACID model, which is C, which stands for the consistency. What it states is that if we go by the normal definition, it says that the state of the system before the transaction and after the transaction should remain the same. Now let's try to understand what is the meaning of the state here. So for example, take the example of the bank. So a bank will store the record of the different customers. So for example, just like you, there can be like 1,000 other customers whose data it will be storing, right? So suppose your transaction, so for example, you are person X and for you the transaction is getting started. So before the start of the transaction, there will be a state, like basically the data for all the other customers' balances stored already in the database, right? So before the transaction starting, there is already a state recorded in the database of the banking system, right? And after the transaction for Mr. X has completed, even after that, the state of all the other individuals, the state of all the other persons whose data is getting stored in the database of a banking system shouldn't change. So in nutshell, what we can say is that, whenever a transaction happens, it should only impact the persons or, the record on which the transaction is to be happening. All the other record which is there in the table, its state should remain the same before as well as the after the transaction. Transaction shouldn't be interfering with the state of the other records, and the state should remain consistent for the other records which are not involved in the transaction. So this is basically the meaning of consistency when we talk in the terms of the ACID model. The third is the isolation. Now, it's a very common phenomenon, right? In these days, when everyone is doing the online transaction, everyone will be updating the account at the same time. For example, you go to a juice shop, right? And they are taking the payment through the Paytm, for example. So at that time, many customers will be paying the same amount to the same Paytm QR code, right? So in that time, many transactions are happening at the same time in the parallel, and they will be competing with each other. Now, if two transactions will be, not isolated from each other, rather dependent on each other, then transaction from the one person can impact the transaction of another person. So in order to ensure that every transaction is successful and it is independent of each other, each transaction has to be isolated from each other, which is guaranteed with the I property of the RDBMS. So this is the meaning of the isolation. The fourth one is durable. The durable means whatever happens, whether maybe the hardware failures or there is a power failure or anything that can happen in any worst scenario, if a transaction has happened, it will be there. The record will be there somewhere. It cannot be lost. What in layman terms, if I can say is that if suppose you are storing your money in any bank, right? Whatever that happens to the bank, maybe the fire arises or their whole system goes down, there will be some way that your data is safe somewhere. Otherwise, you start losing the money. So again, the RDBMS as a feature, they support durability, which guarantees you that once a transaction is successful, whatever that may happen, a power failure or system failure or hard disk failure, your data is safe somewhere stored. It cannot be lost. So this is what the RDBMS guarantees. And as a result of these four features, RDBMS is able to support the transaction feature, which is a very important feature these days, mostly in the banking company, but also in other areas like, in the e-commerce sites or in the social networking site, in which we want to do some kind of operation which should be atomic, like either it should be fully done or it shouldn't be done at all. So this is all about the acidic model, and it is mostly supported in the relational database management systems.
Our deep dive into database normalization highlights the continuous need for precision and efficiency in data management. आगे की सोचो with Upgrad and keep your data strategies innovative and effective for the future.